We are Group 29 and I'm Christine. Our group focuses on the javelin shaft, which are high-performance sport implements that relies heavily on choosing the right material. First, let's look at what happens to the javelin shaft during a throw. When the athlete accelerates the javelin, the shaft experiences high bending forces, torsion from twisting, and strong vibrations during release and flight. If a material cannot withstand these stresses, the shaft may bend permanently, twist out of alignment, or vibrate excessively, all of which affect its flight accuracy. Next, we also need to consider competition rules, which are very strict. They define the required length, mass, aerodynamic shape, and the center of gravity locations. This means the material must not only perform well, but also help the javelin remain within legal standards for competition. So overall, for the javelin to perform effectively, its material must satisfy several important characteristics, which are high stiffness for straightness and consistent flight angle, high strength to resist bending, fatigue and impact resistance for repeated throws, control flaps to optimize aerodynamics, and low density to maintain balance and stable handling. All of this shows why selecting the right material is absolutely essential for both performance and safety. Based on these conditions, we identify several key material properties required for an effective javelin shaft. The first one is yield strength. The shaft must resist bending under high-speed throws. If the yield strength is too low, it may permanently deform, affecting aerodynamics and making the javelin illegal for competition. The second property is the modulus of elasticity, or stiffness. A stiff material stays stable even under rapid acceleration. This helps minimize vibrations, reduces wasted energy, and maintains the correct angle of attack, which is crucial for accurate and predictable flight. The third property is ductility. Although the shaft must be stiff, it should not be too brittle. A small amount of elastic deformations helps absorb impact during landing and prevents cracks. This improves the durability of the javelin over repeated use, especially in training. There are also three more properties we consider. The first is density. A low density material allows better weight distributions and helps position the center of gravity correctly for stable flight. It also makes the javelin easier for athletes to handle. Next is corrosion resistant. Since javelin is used outdoors, the shaft is exposed to moisture, sweat, UV rays, and surface wear. A material with good corrosion resistance will maintain its structural integrity and prevent early fatigue cracking. The final property is cost. An ideal javelin material must balance performance with affordability. It should have a strong strength to weight ratio while still being practical and sustainable to manufacture. With all these material requirements, we can now evaluate which material is the most suitable for a high-performance javelin shaft. That's all from me. Next, I will going to pass it to Mingyan.
Hi, this is Minyan. To proceed with the comparison between properties, we have shortlisted these three candidate materials, which are SZ31V magnesium alloy, 6061T6 aluminum alloy, and also the Ti6Al4V titanium alloy. To manufacture a javelin shaft, the material used needs to have higher value of yield strength, higher value of modulus of elasticity, moderate or high ductility, and this is usually represented by the percentage of elongation. Also, it has to be low cost, it has to be low density, and good corrosion resistance towards the atmosphere. Therefore, we can do a further shortlisting based on the comparison between key properties for these three materials. For yield strength and modulus of elasticity, 6061T6 aluminum alloy and Ti6Al4V titanium alloy are preferred because of their higher yield strength and modulus of elasticity. For ductility, AZ31B magnesium alloy and 6061T6 aluminum alloy are preferred because of their moderate and higher value of ductility. For density, as what I've mentioned before, the one with lower density is preferred. Therefore, AZ31B magnesium alloy and 6061T6 aluminum alloy are preferred because of their lower value of density. and the fifth one, which is corrosion resistance. All three candidate materials have good resistance towards the corrosion in atmosphere, therefore all three are preferred for this property. And the last one, which is cost. Ti6Al4V titanium alloy is not preferred compared to the other two candidate materials because of its high material and manufacturing cost. Such material, which is titanium alloy, it has a much higher manufacturing cost because of its hexagonal close-packed crystal structure, which leads to the low machinability of this material. After doing comparison between key properties for the previously mentioned candidate materials, we can say that the final choice of material that is more suitable to make a javelin shaft is 6061T6 aluminum alloy. This material has a moderate yield strength, which makes it suitable in maintaining the strap profile of a javelin shaft. This material also has a moderate modulus of elasticity. As what we know, modulus of elasticity also means stiffness. This allows a more stiffer javelin shaft can be produced and therefore withstand a more powerful javelin throw from a far distance. This material also has the highest ductility compared to the other two candidate materials. This is important in ensuring the easy manufacturing of long hollow tubes or long rods for the javelin shafts without brittleness. Again, this material also has a moderate density. This is important as lightness is highly promoted to ensure a longer flight distance of a javelin. Apart from that, the material also has good corrosion resistance to the atmosphere. This ensures the long-lasting performance of the javelin and reduces the demands for replacement. Last but not least, this material has the lowest cost compared to the other two materials, which gives us an affordable price to manufacture the javelin. Now I would like to pass the floor to Anselm.
Thank you, Minion, for the clear explanation. My name is Anselm, and I will now continue with the sustainability and socioeconomic consideration related to choosing aluminium for javelin production. I will now start with the recyclability of aluminium. Research shows that about 75% of all aluminium ever produced is still being used today. This highlights how effectively the material can stay in circulation. Unlike many metals that lose quality each time they are reused, aluminium can be recycled repeatedly without a drop in performance. This means a javelin made from aluminium can eventually be melted and shaped into a new javelin or other products while maintaining the same level of quality. Other key point is use energy. Recycling aluminium requires up to 95% less energy compared to producing a new aluminium from raw materials. This measure energy saving directly reduces environmental pressure. Studies also shows that aluminium recycling can reduce carbon dioxide emissions up to 90%. But so by reusing aluminium scraps from old javelins, we reduce waste, lower carbon dioxide emissions, and keep valuable materials in loop. This supports a circular economy where resources are reused instead of being discarded. The reason why aluminum is so recyclable lies in its atomic structure. It can be reshaped and remelted many times without losing its fundamental metallic properties. Aluminum also forms a cohesive oxide layer, aluminum oxide, which protects it from reacting with air. Next, I'll be explaining why it reduces carbon dioxide emissions. Primary aluminum releases about 8 to 12 kilograms of carbon dioxide for every kilogram made. Although this may seem significant, newer technologies like renewable powered smelting are steadily reducing this number. When we compare aluminum with other candidate materials, the advantage becomes clearer. Magnesium production emits about 25 to 35 kilograms of carbon dioxide per kilogram because its process relies heavily on coal. Titanium production is even more carbon intensive, reaching up to 60 kilograms of carbon dioxide per kilogram due to the extremely energy demanding crow process. Besides that, aluminium has also a low density, which means transporting aluminium javelins requires less fuel. This helps reduce carbon dioxide emissions throughout the product's life cycle, especially when shipping in large quantities. Finally, let me explain about the lifespan of the materials. Aluminum alloy 6061T6 forms a protective oxide layer that helps it resist corrosion. Combined with its high strength to weight ratio, this allows aluminum javelins to last for longer periods without deforming or wearing out quickly. With fewer replacements needed, we can reduce resource use and minimize waste over time. Magnesium, in comparison, corrodes more quickly and requires additional coatings to maintain its condition. Apart from that, titanium has an excellent long-term performance as well, but its production cost is extremely high, making it less practical for widespread use in sports equipment. Overall, aluminum offers the best balance between sustainability, practically, and cost. Its recyclability, relatively low carbon footprint, and long lifespan makes it a responsible and efficient choice for manufacturing javelins.
In short, our focus for this project is to find the most suitable material for a javelin shaft, and after we done the analysis, we can see that 6061T6 aluminum alloy is the most suitable material to produce javelin shaft because of its moderately high yield strength and modulus of elasticity. It also has high ductility, low density, good corrosion resistance, and low cost. This material can contribute to sustainability because of its high recyclability, since this material can be recycled repeatedly. This material can also give us reduced carbon emissions because it has low density, and therefore there will be less carbon emissions, especially during the transportation of the javelin. And last, this material has longer lifespan because it has the naturally formed oxide layer, which can prevent the corrosion and thereby reducing the needs of purchasing or manufacturing the new javelin.
This is the list of references for our assignment. Thank you for listening and your fullest attention.